When solving quadratic equations by graphing, it's important to keep in mind that when we are solving equations, what we're doing is we're looking for what the variable equals. Now, unfortunately, solving quadratic equations isn't as simple or as cut and dry as it is as solving for a linear equation. Okay, so kind of stick with me, and this will make more sense as we get to the steps. If you look at the examples here, it says the solution of a quadratic equation in one variable x can be solved or checked graphically with the following steps. Step 1 says write the equation in the form ax squared plus bx plus c equals 0. And I'll talk about what that means in a second. Then write the related function as y equals ax squared plus bx plus c. Step 1 and 2, all you have to worry about is setting the equation equal to 0. And then all we're going to do is focus on ax squared plus bx plus c. So don't get caught up in these steps. Again, when I do an example, it'll make sense. Then the third step says sketch the graph of the function. Remember how we sketch graphs. Our x value, just like we practiced in the last lesson, excuse me, is negative b over 2a. That tells us what our x is. And then we have to plug that back into our formula to figure out what our y is. So we're going to do that. Again, set up your input-output table. So whatever you came up with, your x, y here, and then you have a couple points on either side of it. Okay? Again, when we do an example, it'll make sense. But we're going to be using the techniques for graphing that we learned in the last lesson. It says the solutions, sometimes called roots, are the x-intercepts. Okay? Now, here's what we mean. We set the equation equal to 0. Our y is 0. So our solutions are going to be where our graph hits the x-axis, our x-intercepts. So let me show you an example so it makes some sense. It says solve 3x squared equals 27 algebraically and check your solution graphically. Well, if we solve this algebraically, meaning using algebra, what are we solving for? X. What do we have to get rid of? 3. It's 3 times x, so how do we get rid of it? Well, we divide both sides by 3. X squared equals 27 divided by 3, which is 9. If we want to know what x is, we ask ourselves what number times itself, what number squared equals 9. And we know our answer is a negative 3 and a positive 3. Solving, we're trying to figure out what our variable equals. Now let's talk about how we can check your solution graphically. Because honestly, many of your quadratic equations will not work out so nice as negative 3 and 3. So you will not be able to solve them algebraically. So here's what we mean by our steps here. Solve it for 0. So step 1 says solve for 0. I want this to say 3x squared blah 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 equals 0. So I'm just going to subtract 27 from each side. I end up with 3x squared minus 27 equals 0. And I know you're thinking, why would you do that? Well, this is just how we graph. In this problem, we were able to solve it algebraically. But what about the problems where we're not able to? This is what we're going to do. Now you solve so it's equal to 0. And then you graph it just like we had practiced in the last lesson. Sometimes it's helpful, ladies and gentlemen, to write it out so you have every term there. So we have ax squared plus bx plus c. So if I use negative b over 2a, my b is 0. That ends up being negative 0 over 2 times my a, which is 3. Negative 0 over 6 ends up being just 0. Okay, so our x value is 0. Now we want to figure out what the vertex is. Oops. And I apologize for my stylus kind of freaking out again. So remember, what we do is we set up an input-output table. So you're going to have your x values and your y values. We know our vertex is going to be here at 0. And again, I don't know why that's happening. Okay, so we set our vertex at 0. And then you want to pick a couple numbers on either side of 0. So maybe it just might be easy enough to go -1, -2, 1, and 2. Okay, again, we're using the same graphing techniques from the last lesson. You find your coordinate of your x value, then pick a couple on either side, and then you just plug those numbers into a calculator. So if I get my calculator out here, I'm going to use our formula right here. And I'm going to plug those numbers in for x. So I'm going to go 3 and then -2 squared minus 27. And I get -15. Then I'm going to put a -1 in. 3 times a -1 squared minus 27. And I'm going to get a -24. And then I'm going to put 0 in and get a -27. And then I'll put a 1 in and get -24, and a 2 in and get -15. So we're kind of seeing how it's symmetric. Okay, so now let's graph these numbers on a graph. So if I have a graph here, notice my x values are just -2 to 2, so that can go by 1. But these values here, well, they probably won't work to go by 1s. So maybe we can go by 5s. And we'll make this -5, -10, -15, -20, -25, -30. Okay? Again, we're just checking ourselves algebraically. So plotting the points, we had the point -2, 15. And I'm just going to go by, this is -1, this is -2, this is 1, and this is 2. So -2, -15 would be right here. -1, -24 be right here, about here. 0, -27. Oops. 1, -24. And 2, -15. Now, again, if you draw a smooth curve through these, as we all know I struggle with, especially working with my stylus here. Actually doesn't look too bad if I fix this side. Oops. What we see, if you ignore the kind of slappiness right here, is that I've done a nice job here. We're going to hit the x-axis at -3 and 3. Remember, we set it equal to 0. We set y equal to 0. So where is our y value 0? Our y value is 0 right on the x-axis. So we can say that our solution, yes, algebraically, but if we just did it graphically, it's going to be where the solutions, our roots, are the x-intercepts. So where does our graph hit the x-axis? At -3 and 3. So those are solutions. So when graphing to solve quadratic equations, you look for where your graph hits the x-axis. And again, you're going to have two solutions unless it hits, like, the vertex is right on the x-axis, then there'll be one solution. And if it's floating around somewhere up here, then that's when we say there's no solutions. So the solutions to a quadratic equation are where your parabola, your graph, hits the x-axis.